Okay, just a little update on the battery. So I've got the BMS managing the output. This tester here shows the voltage directly at the battery, so that bypasses the BMS. And it comes out of here. I'm going through a shunt so I can measure the current of the load coming out. And in theory, well, no, it's just the load, because I want to be able to measure the charging current, but unfortunately that's coming directly into the charge controller, and right now it's not charging. So I'm trying to run it down to see, one, how long it lasts. And I've got my fan running at full throttle, plugged into a 600 watt inverter running directly off the load of this battery. So far it's been running for an hour and 15 minutes. It's down to 27.6 volts, and it's the inverter and the fan are pulling 2.85 amps, 78 watts. So I'm thinking that, I don't know this for sure, I don't know anything about this charge controller. It was super cheap. I think it cost like $7. And it's designed for like solar lights. So during the day, when there's light on the solar panel, it's supposed to charge the battery and turn off the load. And then at night, when there's no light on the solar panel, it turns that feature off, runs off the battery, and turns on the load. I don't have a load hooked up to it right now, and I do have a charger hooked up to it right here. That charger is that, and it's 29.5 volts at 1.5 amps. But as you can see, there's no, PV is for photovoltaic. That's the, if it were solar panels in it. It shows as 1 amp is as 0.1 amp is the load, but there's nothing really plugged into it. The 17 is just the setting for the load. It means I have the load always on. That 29.4 is the incoming power from the charger, but it shows 0 amps. So currently it's not charging, and I don't know why. So I'm hoping that if I run it down to a certain level, maybe there's a threshold that this thing is preset to that will turn on the charging circuit once it hits that voltage. As you see right now, it's 27.6. Once this hits nominal voltage, it'll be 24 volts, which is what the system's supposed to run on. And we'll see. But at this rate, it's been running an hour and 17 minutes, and it's at 27.6. It's going to run for a couple more hours before it hits that. That's where I'm at. If worst case scenario, I have to run the charger directly to the battery from here. Actually, what I would do is I would take it out of the charge controller and actually run it directly in here, so that it would run into the battery management system, so that it can control the balance on each of the stacks. All right, well, that's where I'm at. It's my whole workstation is a mess. I'm still charging batteries. I have more batteries. The idea is to create another one of these. So if all of these are at max capacity, another one of these would give me 1.5 kilowatt hours of storage of capacity. In theory, in reality, it's probably going to be more like 1.2, but still, that's a lot. And I have everything I need other than these plates this kit, which is really cheap online. A 1.5 kilowatt hour solar generator is between $1,500 and $2,000, and all I need is this kit, which is $80. So from what I've got going, I should be able to have quite a system for next to nothing compared to buying one outright. Doing it this way too, building them from scratch, you save a lot of money the bigger you go, because even no matter how big it is, you got to buy stuff like this. This was $7, and I think this was 20. So the little bitty ones, there's not a big difference. This was 700 kilowatts, so it is a big difference here. I mean 700 watt hours. If I can double this size, then yeah, it's gonna make a huge difference in the price. I need to clean up my lab is yeah. Anyway, my 3D printer. Anyway, this is where I'm at. I'll keep y'all updated. I have to get something to put all of this in. I was gonna put it in this. Started to build it out, but the inverter's too big. It's too tall. So I'm trying to figure out a way that maybe I put this into something else, or get something. I'm looking at those. Harbor Freight has alternative to Pelican cases that are a third of the price. So I'm looking at that, but we'll see. I just wanted to get it all functional first, because I can run it like this, and it's been running my fan no problem. And this is a pure sine wave inverter, so if we actually had a power outage now, I could power like my server down there. I could run it off of this, but I've got it on its own battery anyway. But like a CPAP machine, I could run this. It would run a CPAP machine for probably a couple days just on this battery, at night. I don't have any solar panels to charge it back up right now, but there's no power outage right now, so I can charge it up during the day. Anyway, all right, that's where I'm at. I'll keep you all up to date, and as this project progresses, if it grows, I still have all of these cells to test. They're all charged, so that I know they all take a charge. Those have already been tested and are ready to go. Those are bad, so out of all of those wouldn't take a charge. These all need to be tested for capacity, and if they don't meet the requirements for the capacity, like some of these here are supposed to be, I think, let's see if it says on it. It says 2,200 milliamp hours. So if it's not within probably 80% of that, then I'm not going to use the cell. The cell's bad. Some of these are actually really good. Some of them are 3,200 milliamp hour batteries, and anything like that, it's going to be set aside, because the bulk, like these are all 2,700, and I want to keep it as close as possible to the same. All of these, there's 7 in each one. Every single one of them is roughly 2,700, so the average of the whole thing is 2,700 each. It's easier to calculate what the capacity is of the entire battery if everything is matched like that. Plus, you don't want it to balancer, so you don't want this whole stack right here balancing this stack, because this one has a lower voltage where it runs out sooner. Then the rest of the battery has to work to actually charge this one back up before, so one cell can actually lower the capacity of the whole battery, because all the rest of the batteries have to work to balance that one cell. So there's a lot of testing that's involved before I can put it together a battery. But it's working. It's we've got almost an hour and a half now. It's down 1/10 of a volt since we've been talking. Yeah, I mean, it's actually doing its thing. It's doing what I wanted it to do. I'm excited. Once it's all packaged in a case that I could take around with me. Oh, inverter just fan turned on. I'm gonna take that as a cue. All right, that's my setup. I'll keep y'all up to date. Thanks for watching.